Hello, everybody. Welcome to the last talk before lunch. My name is Matt Davis. I am a site reliability engineer at OpenX in our platform engineering team. A little bit more introduction just about me and OpenX. I do a lot of music kind of stuff. I like to compare music and art to technology and talk about it, which is what I'll do today. OpenX, if you don't know us, we're an advertising technology platform. We do real-time bidding. We connect advertisers and publishers together through advertising exchanges. And we do all this through very large distributed systems that we have all over the world. We're also in Pasadena. Here's an obligatory icon slide. Some of our technology that we use, some of the volumes that we deal with, a lot of distributed stuff going on here, a lot of Hadoop, a lot of React key value store, and a lot of data pipelines for our events. Now, this talk is really about indeterminacy. Indeterminacy is something that we see in everyday life. It's something that we see in music and art, and it's something that we see in computing. David Tudor was a pianist who worked a lot with a composer named John Cage. Now, David Tudor worked a lot with indeterminacy. You can see this piece called Rainforest here is actually an arrangement of objects and everyday objects, musical objects, planks of wood, things hung from the ceiling. You can see there's some mics in there, and there's all kinds of little wires going in between things. And those are actually contact mic'd and then run back into David Tudor's mixing arrangement, his electronics. So the audience would go around this piece, and the audience would hit the things in the room. And that indeterminate action of the audience making those sounds makes up the piece. So David Tudor and John Cage worked a lot in this realm. Indeterminacy was what they were all about. They had specific approaches to composition and to performance that they intertwined chance operations and indeterminacy. Now, John Cage had this ability to create these scores that were, you couldn't put this down in front of you on a piano and play it. Kind of unintelligible, you might say. This particular one is a bunch of transparencies that he would just drop on top of each other. And so that indeterminate action created an indeterminate score. Here's another example, solo for piano. This is one that David Tudor actually had to look at the score and figure out what is he doing here, and then figure out some way to make this performable and repeatable, actually. So he would actually look at this score and make up a score of his own. So indeterminacy in music has a lot to do with those types of objects that are being used, the instruments that are being used, where they're being used, what we hear around us, what the audience is making. And the audience, those people in the audience, are also indeterminate. You know, we go through our lives every single day and these indeterminate things happen. Either they happen to us or we make them happen. And they give our lives this kind of a form and a structure that we sometimes don't even know existed. So online advertising is for all these people. And all these people are making all these indeterminate decisions. So that affects our systems. There's a lot of different kinds of indeterminacy that happens in distributed systems. All kinds of things like a visual consistency, traffic spikes, market forces, bursts, special events, and then stuff that happens in the data center. You have machines go down, you have machines partially go down, or you have an entire network go away. So ad quality is something that OpenX is really, really engaged with. We want to make sure that when you go to a site and you see ads on that site, that they're applicable to you. We want to make the whole experience of advertising on the internet non-annoying. Sometimes you can't get away from that, and sometimes we can't necessarily control what our publishers do, but we can give them a certain amount of quality from the ads that are coming from the market that they show on their page. We have two different kinds of ad quality at OpenX. We have something called traffic quality, and that's more like a blacklist. You know, we'll get a certain type of user or a certain type of network or a certain type of something, and that ad network is, you know, displaying an ad that, you know, we don't want to display. Or they're doing something like making too many requests. So we'll blacklist those people. Not people, more like networks. But ad quality is specifically about the actual ad, the actual picture, the creative. You know, what is that ad showing? Is it making sound? Is it video when it shouldn't be? Stuff like that. So the way that ad quality does this is we actually go out and we scan. We have this scanner network, and this scanner network goes out, it crawls our publishers' sites, it simulates an auction, and then it looks at the ad that won the auction. And then it actually has recognition technology, like I was saying, to see what the image is, or if sound is coming from the ad, or like I said, video or something like that. So all of that data gets fed into this data pipeline. Like it mentions here, that's a Kafka Storm, MariaDB type of thing. And REAC is the backbone of that data serving. That's where our delivery systems come in and get information about whether or not that ad should show up. So when we built ad quality, we decided, well, this is kind of cool. Look what we can do. Look what we can actually see what the ad is automatically and be able to, you know, display it or not display it. And it was kind of an experiment. And I think a lot of products like this start off that way. They start off as experiments. Well, this is one experiment that got really, really popular right away. Our publishers really liked it because they, not only did they have the automatic ad quality engine that we built, they could also go into their configuration management and decide which ads they don't want to see. So there's an automated portion of this, and there's a manual portion of this for the advertiser or for the publisher. So we, SRE, were told, this is awesome. Can we make it full scale in like next month? Well, full scale meant growing a system times 5. And that's what they told us. They said, we have this much traffic coming from these publishers and these advertisers. We know that we're 1/5 of our total capacity, and we need to multiply things. Well, we couldn't just multiply things. It's not linear that way. You can't just multiply something by 5 and have it work. There are a lot of different factors that came into play with that. Front-end traffic coming from the client was one of the biggest ones. We would have had to multiply our React clusters to be 200 and 300 node clusters, which isn't totally insane, but that's really big. So this is a quote that I heard a real-life person tell me at a conference in a bar, implying that sysadmins were problems, that sysadmins didn't understand development. And I have a background as a sysadmin and as a hardware person. I'm not a developer or a programmer. I do my own amount of scripting and coding, sure, just like everyone does. But I didn't like this, and I didn't like that attitude. It's this weird, we don't want to work with SRE attitude. So I came up with this other term. I call it OpsDev. And it's tongue-in-cheek. We all know what DevOps is, but maybe we don't. I like to think of DevOps as an idea. It's not a title. It's not the name of a group. It's a way of working within your organization. A lot of the times, we think of DevOps as being the developers moving into an operational space. Here, I just want to think about the operators moving into the development space. Not being the angry sysadmin is what I call it, or don't be a jerk. But be stern. You know, reach back into dev. The SREs and the sysadmins have a unique perspective of being able to see everything at times. And knowing the flavors of indeterminacy is really important. So here's some Grafana stuff. These are some React charts. So we had a real big issue with this ad quality system literally the same week we decided we were going to scale it. Something happened on the outside, an indeterminate action in one data center, in fact. It only happened in one region. And we don't even know to this day what happened. It was almost like a publisher turned on something in their configuration which made all this new traffic flow into our ad quality system. You can see that here. You can see how the load average there spiked up to 16. These are only 16 core machines that are at this time. But what you can also see here, if you're familiar with React, if you're not, the Git siblings indicates the number of nodes in the cluster. We added nodes to the cluster right away, and we were able to get our overall load average down and fix that big, huge latency spike that happened. So this was an example of the operators, the SREs, the sysadmins, being able to see something objectively and then talk to dev about what we need to do to be able to scale this. So we initiated a project. We said, okay, we're going to scale this, we are, but we're not going to scale it until we fix stuff. And what you see here, these are three different regions, 3 different data centers that we run. And you can see how the top is the operations per second, the bottom one is the load average, and that's a cluster-wide view. So as soon as we were able to scale this cluster, we were able to see those load averages go down. But these graphs were really important. These metrics were really important for us to be able to, number one, know what's happening, and then number two, see how the fix helped it. So we actually talked about putting in a cache layer. And over the course of maybe, I think it was like 2, maybe 3 sprints, we introduced caching in 2 different areas of the application. Actually, we have 2 different front-end layers. Each one of those front-end layers had caching, in one case, enabled. It wasn't there at all. And in the other case, changed so that it had a better hit rate. That's how you can see these different levels where the peaks of ops per second jump down to another peak, they jump down to another peak. Those are the different times that we started inserting our different caching strategies. So let's go back to John Cage and David Tudor for a minute. This is that score, the solo for piano that I showed before. Now, David Tudor's job, like I said, is to make this performable. How do I make this performable and repeatable? So he actually built his own score. He took a real set of notes instead of these squiggly areas that John Cage indicated. David Tudor went in, interpreted it, figured out the notes on the piano that he really wanted to play, and he's got some other kinds of symbolism and stuff in there with the lines and stuff, but that was the score. Now, someone else may look at John Cage's score and do this completely differently, but David Tudor wanted a score that he could take and perform this piece, and he would take his score every time, performable and repeatable. So that's really important when we're talking about operations, talking about distributed systems. It's really, really important to make things performable and repeatable. So we have things like configuration management. We have things like standard sizes of equipment. When we were looking at this ad quality problem, after we worked back with dev, after we worked as a team to get those caching layers going, which as a result balanced the processing load over a larger number of systems, we were able to basically apply a formula. We were able to do something that would be repeatable in every single data center that we have this cluster. And these are some of the bullet points that we went through. Probably the first one was the most difficult one, just figuring out what kind of ops per second can we handle within the cluster. Measuring trends, again, looking at the metrics, looking at monitoring, looking at the history of how things performed, and really looking at the entire history, not just points in history. That's really important. You can't just look at one single event and go, oh, well, I can't handle it because of this. You have to look at all the events. You have to look at the entire history of how that cluster has been behaving. By the time we got through all this and we added in overhead for disaster recovery, for data center failover, assuming some future growth, we finally got to that 5x scaling factor, and we were able to grow these clusters so that they weren't enormous clusters that are unmanageable and inefficient. So we did a minimal impact migration here. We had to separate one use case from another. We had that traffic quality use case running on the same cluster as the ad quality experiment. Well, now the ad quality wasn't an experiment anymore. We needed to separate them. So taking the formula from before, we built a brand new cluster. This says V1 and V2. We actually went from React version 1 to React version 2. But that gave us much better visibility into the specific use cases that we're running on each different cluster. Now, we're able to actually scale the cluster, make it GA, and make it not be an experiment anymore. So here's some more pretty pictures. This is the time where we did the actual migration. On the top, you can see the traffic quality. So that was when both were on. You see the big blue, and you can also see this is the same span of time of those other graphs. You can see those step downs from the caching being added, and that's the entire cluster. Now what you can see is on the bottom, those big spikes. That's data being copied from one cluster to another, and then you see it kind of even out. So we let it run. We built one cluster the exact same size as the other cluster. That way, we can see the real effect of what's going on operationally. We can actually see the metrics. We can clearly see the metrics. And then we know what to expect when we grow something, when we scale it. So the next thing you can see in these graphs, once we got ad quality off of that traffic quality cluster, traffic quality, nice and smooth kind of there. No more big events like that. And we let ad quality run on the same size cluster for a couple of days or a couple of weeks there. And then we started scaling. So you can see us add a little bit more at the beginning as that blue operations per second get rate starts going up, and it goes up in stages, up and up and up. That's us adding more and more nodes to the cluster. Same thing with CPU load averages. Again, cluster-wide average for this one. You can see where we had very, very high load when the two were together. You can see the caching, the steps going down, and then you can see where we pulled them apart, put ad quality on its own cluster. The really kind of interesting thing about the ad quality graph is that you can see how in this graph, the operations per second go up because we were adding more nodes, we were adding more traffic as we added those nodes. You can see here how in the beginning, as we didn't have as big of a node count, the load averages were higher. We started adding traffic and they get higher and higher, but then we finally got to a point where we balanced out the traffic with the load and it looked much better. So I always ask myself this question, what is at scale? You always hear that term, at scale. Now, a lot of the companies that are here are really big, and they operate at scale. I would say that OpenX operates at scale. But what does it mean for a smaller company to figure out how they operate at scale? And it all has to do with steps. These are all steps to getting to scale. Really being able to work as a team, like I said, look at history, look at trends, not events. Events are cool, they give you information, they tell you neat stuff, but when you want to scale something, you really need to look at the trending behavior. Flexibility in deployment is so important. When you have You can have all this cool stuff, metrics and monitoring, looking at your trending, but if you don't have configuration management that lets you do things very easily, lets you scale quickly, lets you deploy 100 machines at once, then you're going to slow yourself down. I like good operational resources. I like structural homogeneity. We only have really one certain kind of server that we use for certain use cases. We don't have like a 24-core server over here and a 16 one over here, or something with SSDs over here and spinning disks over there. We just have one kind of server, SSD, 64 gigs of RAM, and 24 cores. Things need to be evenly balanced, and the thing that configuration management, that homogeneity, really adds to being able to evenly balance things. And just like the David Tudor, John Cage example, really repeatable operational procedures are really key, not only to speed and velocity of deployment, but also to getting your staff and your teams to be able to understand what's going on. So that's why I like to say scale is step by step. Scale is not something that you measure, it's something that you build. It's just like music. It's just like a tonality in music. When you have a scale in music, you go up, you know what the notes are. You know what the map looks like, and you're going to a place. You're going to a place that's defined precisely and is expandable. And all of those elements add in to be able to grow your business and grow your clusters and really be able to run at scale. Thank you.